of all, very good morning, and thanks for joining the session. So today, as the name suggests, like as the name of the webinar, trends in GeoAI means, so we'll be discussing about various trends, new capabilities, tools, and functionalities for GeoAI within our ArcGIS ecosystem. So we can start the session. So this will be our agenda. So we'll be touching upon what GeoA is, and we'll be discussing about few terms, what exactly means, and what is the GeoA workflow within ArcGIS, and we'll be discussing about the GeoA use cases and workflows for imagery as well as tabular data, and we'll also discuss about natural language processing. What are the NLP models available, and what can we do with that within ArcGIS? And pre-trained models. What are the new pre-trained models available within ArcGIS Living at List, and how we can use it? And we'll also be touching upon some of additional new functionalities and tools that is out there in the latest releases. So, yeah. So before like going to the presentation in detail, I would like to touch up in detail some terms. So like most of us are aware of this terms only, but I'll just briefly go through it. So first term, artificial intelligence. So this is a very trending term nowadays, right? So it is basically the simulation of human intelligence in machines, which enables the machines to learn, reason, solve problems, and help make decisions. And machine learning is an application of AI that will allow machines to learn without being specifically programmed. For example, they can extract knowledge from data through various methods and algorithms. For example, like linear regression, decision trees models that we'll be using to extract unstructured patterns and insights from this tabular data. So likewise, machine learning comes as a subset within artificial intelligence. And next come to another term, deep learning. So deep learning is also a type of machine learning which is based on artificial neural networks, and it uses multiple layers to progressively extract high level features from the raw input. So it uses more advanced methods and will helping in solving complex issues across large data volumes, and it has a particular focus on analysis and these pattern recognition workflows. And the next term, generative AI. So it is also trending nowadays, right? Generative AI with the release of this ChatGPT, DeepSeek, Cloud AI. So it's, as its name suggests, it generates. It will help us in generating new data such as text, images, videos, audios, and 3D models. And we also have this term large language models. So large language models are trained on like basically large volumes of data, for example millions or gigabits of text from the internet, which will be helping us to understand and generate natural language. We can do classification within natural language using this large language model, text translation, like text generation. So all those things are possible with this large language models. Like these are the terms that we'll be generally using when it comes in the context of artificial intelligence, right? So we also have this new term, AI assistant. So AI assistance is a new functionality that is being introduced in various platforms of ArcGIS, which will basically help us to automate and accelerate your workflows. And it is being integrated in various our products. And soon it will be a very ready to use and very helpful product that will be helpful in accelerating your day-to-day workflows within the ArcGIS ecosystem. So yeah, so all this comes within GeoAI only. So we have seen these terms, right? AI, machine learning, deep learning. I mentioned like what exactly that term is referring to. But what is GeoAI? So as like it has a spatial or geospatial component within the term itself, GeoAI. So GeoAI is nothing but it advances or it enhances the science of GIS with AI tools so that it will help us in automatically doing this information extraction from imagery, vector, tabular, and text data, so that we can analyze it on a bigger scale, or we can see it at a bigger picture. So it is very helpful in our day-to-day workflows in automating our complex workflows and to reduce the manual effort in this repetitive task. So GeoAI is helpful in various use cases and various workflows, which will reduce this manual efforts and labors to a big extent. So how we can leverage this GeoAI functionalities within ArcGIS? So I talked about this AI terms, GeoAI term and all, but how exactly we can leverage this within ArcGIS? So AI, as we can see, it's like showing remarkable progress everywhere, right? So with today's AI techniques, we can see and perceive now. We can read and comprehend. We can analyze and interpret data, and we can create and generate even human-like text and even art. But how we'll be able to leverage those functionalities within ArcGIS? So within ArcGIS, this can be applied to many different data modalities. We can apply this computer vision techniques to imagery, 3D data, video data, text data. So for the text data, we'll be using this NLP techniques, and we can apply this machine learning and deep learning techniques to vector, tabular, and time series data. So while we can view this from this perspective of this data modality, in the end, it's really just about solving various problems. For example, like extracting or generating spatial data, analyzing spatial data to discover unrevealed patterns, or to discover hidden insights out of it. So in the rest of the presentation, I'll be touching each of these workflows in detail, and at the end, we'll be having a demonstration on some of the workflows as well. So in short, it can be applied with different forms of data. So in the presentation we have, I highlighted some of the data formats that we mainly use for this GeoAI functionalities within ArcGIS: imagery data, tabular data, vector data, unstructured data, and even in full motion video also we can have this capabilities, lidar and point cloud data to extract this 3D objects, or for classification of this point cloud. So basically, it covers a wide range of data formats, and it can be used for a wide range of workflows and use cases as well. So we can touch upon the first thing, which is the most common workflow that we'll use. That is feature extraction from this imagery, three-dimensional data, and a video. So as you can see, GeoAI has come a long way from simply processing this overhead imagery. So ArcGIS now supports a rich varieties of data formats and analytic tasks. So you can use this GeoAI with scenes, time series data, even 360-degree street level imagery, and field level images that is captured on the go from our mobile data. So this comprehensive approach allows us for a deeper, more holistic understanding of our world, and what we can do with all this data. So I just mentioned that we can use all this data for this GeoAI workflows within ArcGIS. But what exactly we can do with this workflows? So I can say that the functionality of the workflows that we'll be able to do with this techniques can be limitless. So it can differ from department to department. It can differ from workflow to workflow. So we have all these functionalities embedded within a single umbrella, so that based on the use case and the workflow that you are going to perform, you can use the functionalities accordingly. So we have integrated everything together, so that we support different types of data formats within a single platform, and we have integrated a different kinds of models, and you have this freedom or privilege to select the model based on the use case that you're trying to perform, and you have this ability to retrain or modify the model if you feel that it is not performing well for your workflow. So we support this the sense of like deep learning model architecture that will be very useful for a lot of users. But sometimes we feel that as there is a dozen of deep learning models, we will be confused like which model exactly we want to use for our workflow. So in that scenario, we also have this new functionality called automated deep learning or AutoDL tool, which will basically analyze your data and will suggest your best model that will be fitting your data. So in that case, you can like if you are stuck with the workflow, and if you are stuck in the beginning like which model you have to use for your workflow, and you want to make sure that the model that you are trying should give proper accurate results for your data, you can use this advanced functionalities like AutoDL and Auto Deep Learning tool, which will help you in getting the best model for your training data. So all those functionalities are also part of this GeoAI. And now we can move to this prediction task. So in this slide, I just mentioned about this imagery, two-dimensional, three-dimensional, and even the video also, we can do this like extraction and object detection workflows. And now it comes to the prediction task. I think it will be the probably the most common GeoAI application behind this feature extraction of imagery. And this analysis of spatial data range from this very simple to even advanced interpolation techniques. And we can also have this generalized linear regression, spatially explicit techniques such as GWR or multi-scale GWR techniques within ArcGIS. And we also have this presence only prediction model, which will be helping you to make prediction based solely on presence data. For example, you can make predictions of presence of a plant species or animal species. So for all those workflows, we can have this presence only prediction tools. And we also have this causal inferencing tools, which is a very good tool which will help you to move beyond just association and prediction. So basically it will help you in identifying the association of each of these explanatory variables with the outcome, so that the prediction will be more accurate and you will be able to identify the association of the outcome with each of the explanatory variable. So sometimes when we are doing this prediction task, we'll be having this set of explanatory variables, and we'll be using that explanatory variable to get an outcome or prediction, right? So using this causal inference analysis, you will be able to model like how each of the variable is influencing the outcome separately, so that you will be having an holistic understanding of what is the significant influence of each of the parameter on the prediction or on the outcome that you are trying to generate. And as I suggested, like as I mentioned in the previous slide, we also have this multimodal auto ML tool, which will help you in getting the best fit model or best fit algorithm for your data. So it will be considering a set of parameters. You can give your data, and it will fine tune some of the major parameters, and it will run that model for certain epochs in your training data, and it will suggest the best model that will suit your data. And you can also have this the command this interpolation techniques like empirical Bayesian kriging, like that. So likewise, you can have this analysis of spatial data with multiple tools and multiple algorithms. And like it is not limited with this just the functionalities that I have just mentioned here. So these are some of the major algorithms or major tools that we use generally, and the scope is beyond this, and it can vary from your use, like from between use case the scope can vary. And now I'll just touch upon this natural language processing workflow on unstructured data. So basically, when it comes to GeoAI and ArcGIS, it is basically comes in three sets. First is it can deal with imagery, both three-dimensional and two-dimensional imagery. And next, it can deal with this vector and tabular data. So all those things we just discussed in the previous slides. And the last one will be the natural language processing models, which can work on this unstructured data. So unstructured data means that we nowadays we are getting loads of data out in the form of this unstructured PDF documents and all, right? So it is very essential in some of our workflows or some of our cases where we have to extract the spatial information from this unstructured data, right? So most of the times like geospatial data won't come nearly packaged in the form of feature classes and geodatabase. Often sometimes it will be buried in the form of reports, and we may have to extract insights out of it sometimes, right? So for that, ArcGIS has tools and pre-trained models which will help us in extracting information from such text using NLP techniques. We can have different workflows, and major workflows that we have is text classification, entity extraction, text transformation, and text translation. So we are now seeing this emergence of this large language models like ChatGPT that can be prompted or which can be given a few examples to perform a task, right? So we are also trying to integrate the capabilities or similar functionalities of these models within ArcGIS, and you can use them to extract information from text without needing to train your own custom models. So we support different classification problems. So just as I mentioned before, so the major workflows that we support is, one is text classification. So text classification means that you will be able to assign a label or category to a text from your unstructured data. For example, if you are having dozens of this crash reports or some other intelligent reports that you're having, and if you want to classify those text information into a defined set of categories, you can have this natural language processing models to automatically classify your data. And you can also have this text translation model which will help you in translating the model from one particular language to another model. Or you can also have this address standardization workflow with this text translation models. And other one will be this entity extraction model. For example, if you are having some instant report and it is having so many spatial component within it, it might be having some address information, it might be having some place information, but if you want to automatically extract those spatial information from such kind of reports, you can develop or you can have this entity extraction NLP models which will basically help you in extracting the spatial information from it, so that you'll be able to map the output in a two-dimensional map, so that you can analyze or visualize it better, and you can inference it for various kinds of purposes, and you will be able to use that for further analysis as well. So likewise, you can have this classification, translation, and entity extraction models within ArcGIS, which is NLP based large language models.
Shribhatra, sorry to
Yes.
interrupt your flow. So there is a
Yeah.
hide button on your screen, right? Can you use that to hide the tab?
Yeah.
Thank
Okay.
you.
Okay. Yeah, so we have discussed what kind of workflows that will be able to perform in ArcGIS, right? But what are the steps in that? Like how we'll be able to do that practically, and what are the tools available for that, and what are the methods available for that? So here in this slide, it is showing an end-to-end GeoAI ecosystem. Basically, it is showing or visually representing the conventional deep learning workflows that we have, right? So in any of the traditional AI workflows, it will be having some set of practices or best practices that will be performing to train a model, right? So these are the steps in it. It starts from the data access and it ends with the inferencing or prediction part or detection part. So in the data access part, we can leverage like different kinds of data formats. So since ArcGIS supports multimodal data and different kinds of data formats, we can fetch or we can access different kinds of data format, and we have this out of the box tools available which will help you in preparing the data, labeling the training data, And once we have that data ready in the appropriate format, we can use that data for model training. And once our model is trained, and if you are satisfied with its accuracy and if you are satisfied with its performance, we can deploy the models to production, and we can consume that model for running the inference at a large scale, so that when we are running the inference, we can take action based on the outputs that is being generated by the model. So it is an end-to-end ecosystem. It starts from data accessing, and it ends from taking an action, or it ends from it ends with solving a particular problem, or something that is really challenging to you. So some most of the real world challenges that we are facing now can be solved using this automated AI models, and we can develop custom models with our data. And using this out of the box AI models, you'll be able to perform this uh, classification model workflows, extraction, detection from the video. So all those things are possible with this tools within our ArcGIS ecosystem. But sometimes we feel that we don't have enough data to train a model, and we feel that we don't have that enough resource to train a model, and we don't have that hardware to develop such a high accurate model and all. So in that scenario, like, we can have this privilege of skipping these three steps: data preparation, data labeling, and model training. So most of the times we'll be preparing this step when we don't have the adequate training data for developing a model. So if we want to prepare the skip these steps, we can use a pre-trained model instead of these steps. So most of you guys will be aware of this S3 India Living at Less page, right? So it's like a repository or hub where you can find different sources of data, imagery data, vector data, and the pre-trained models in the form of deep learning packages are also available in the S3 India Living at Less page. And if you want to use this pre-trained model readily for any of your workflow, you can skip these three steps: data preparation, data labeling, and model training. And instead of that, you can use this pre-trained model which is downloaded, and you can directly go to this uh, deploying models or consuming the models for this inferencing process. So it is a very easy workflow that you will be able to perform with this pre-trained model. So as of now, we have a 92 pre-trained models available in our ArcGIS Living at Less, and these models are making this geospatial AI easier than ever. So you can use them as it is, or you can use them as a starting point when you are creating your own model. So we have this different models fine-tuned for different geographies and various use cases. So some of the models may perform well in India, and some of the models you may have to fine-tune or modify for the Indian scenarios. So we'll be having a guide associated with each of the model, an overview page describing about where the model can be used and what is the kind of imagery that is supported by the model. I'll be just showing the model page also, so that you will be having an idea on how it is looking like for those who are not familiar with. So this pre-trained models are readily available and it is ready to use, and we have various foundation models also integrated with this. And one of the recent addition is the segment anything model. So segment anything model released by the Meta, which have this capability to segment most of the general classes within an imagery. So that segment anything model is also integrated within our ArcGIS ecosystem, and that model is available to download as a DLPK package. And the segment anything model, we have again fine-tuned or modified or enhanced its functionality by giving this text prompt functionality, and it is called text SAM model. And this text SAM model can mainly work based on this text prompt. So the limitation or the challenge that we were facing with this SAM model or segment anything model was that it used to classify all the classes within an imagery. But sometimes if you are having an imagery and we'll be interested in classifying or extracting a particular term class from the imagery, right? So the imagery will be having different objects or different components. It will be having trees, it will be having buildings, it will be having cars and vegetation regions. But sometimes we'll be interested in just extracting the buildings from the imagery, and sometimes we'll be just interested in extracting the trees from the imagery. So in that scenario, we were having challenges with the SAM model because it used to classify the entire imagery into different classes. So instead of that, the method or the functionality that we have introduced is TextSam. So it can work on the text prompt. So here you are seeing some snapshot of the result it is generating. So this is a airplane classification it has given. So the text prompt that we have given was airplane, and from the imagery it automatically segmented the airplane, and we'll be getting this extract bounding box or extract segmented output from the imagery when we are using this TextSam model. So it is a very a new addition that we have, and it is very useful for most of the workflows, day-to-day workflows that we have. And what's new in GI? Like, what's the apart from this TextSam, what are the tools and functionalities that is there in the latest version of ArcGIS? One of this new functionality that we have is this uh, provision to detect object from this oriented imagery. Oriented imagery means we'll be having this 360-degree street level street view imagery, right? So that has been collected for this assessment of road assets, or for getting count of this road features and all. So the street view imagery, now we can directly use in our out of the box tools within ArcGIS to extract features directly out of it. So here you are seeing a snapshot of the result where it is extracting the street features as a bounding box from the street level imagery. And we also have this new depth estimation model. So the depth estimation model will also give you two kinds of output: one metric output and a relative output. Those kinds of outputs will be helpful in identifying the um, depth of object within an imagery. So if you want to estimate a pit depth, or if you want to identify the relative position or relative distance between two objects within an imagery, this depth estimation models will be very helpful. And that is also a recent addition, and it's a pre-trained model that is available to download from our S3 India Living Atlas. And one of the other new models that we have integrated is this climax forecasting model. So this climax model can help us in doing this weather based forecasting or environment based forecasting activities, which is actually a time series based forecasting model, which can be trained with our own data, and we can define the workflow that model has to perform. We'll be able to use that model for this different forecasting workflows like precipitation forecasting, temperature forecasting, all those scenarios and all. And other new model that I would like to highlight is this clip zero shot classifier, and that was also recently added, which will help us in classifying the images based on the training info it already has. So it is also a pre-trained model. If we give some images to it, it will help us in classifying the images based on the set of classes that we are defining it. So that clip zero shot classifier is also a relatively new model, and it can be very helpful in some of your workflows. And other one is this Mistral AI model. So Mistral AI model is a large language model, and it is based on this decoder based large language model, and it has been trained using around like 7 billion parameters, so that you will be able to efficiently use it for the text classification workflows. So this Mistral AI model, you will be able to fine tune or modify it for the automatic text classification from this unstructured text, reports, social media post and all. So that Mistral AI is very useful when you want to create your own this LLM model without creating or without training a model from the scratch, this Mistral AI model is very useful in those kinds of aspects. And other one is like we also have this 3D feature extraction capability now, where you will be able to extract this 3D feature from this 3D scenes and all. So that is also like a enhanced functionality that we are having in this GeoAI capabilities. So these are some of the new additions that we have. Now we can just proceed to some of the demonstration. So I'll be covering these many things in my demonstration. I'll be showing the feature extraction workflow using the TextSam model, and I'll be showing the new functionality that we have where we are able to extract this features from the street view imagery. And the next one is this text classification using Mistral AI, how we'll be able to automatically do the text classification with this Mistral AI model. And at the end, we'll be ending with this predictive analytics workflow, where we are using this CO2 predictive analytics model and further enhancing the results of that model for like estimating the CO2 emission that is released by a wildfire in Bandipur National Park. So these are the use cases that I'll be covering in my demonstration part. So let's go to the demonstration part. So first I'll be showing the TechSam workflow. So as I mentioned in this presentation, the TechSam, the text segment anything model that we have can actually work based on the text prompt. So here I am having an imagery. It's for this Mangalgiri region. So I have used a TechSam model for extracting the building footprints from my image. So as you can see, it is a very clustered region, and I wanted to extract the building footprint automatically using the TechSam model. If I am doing it manually, it will be a very tedious process. It will take many days or months to complete for this entire things, right? So I just clipped out a small region of interest from the Mangalgiri region, and I tried out the TechSam model for that region. And this is how you will be using that model. So you can give your input imagery, and you can define this output name, and here you can add your TechSam model, which is readily available to download from our Living Atlas page. I'll just show you how it is like visible in our Living Atlas page. So in the S3 India Living Atlas page, if you search with the keyword DLPK means deep learning package. If you search with the keyword DLPK, you will be able to see the available pre-trained models that we have, and it is for different functionalities and it is for different use cases. And you'll be able to download it from here itself as a DLPK package. So I'll show just an example. So this is this land cover classification model. If you want to download it, you can just click on it, and if you click on it, an overview page will be opening it, and it will be showing all those details and all, and you will be able to download it from here. So similarly, I have downloaded the TechSam model from this Living Atlas page. I'll just show you how I downloaded it. So this is the TechSam model that we have, and if you click on it, it will just take us to the overview page, and in the overview page it will be given all the details, all those things. So here you can see that it supports 8-band 3-bit band imagery, and this model can be fine-tuned. And if you feel that this model is not performing well for the feature extraction for your region, you can fine-tune this model, and it is applicable globally. This model is expected to work globally, and these are some of the sampled results it has for various objects: cloud, solar panels, airplane, vehicle, car detection. So you'll be able to download the model from here. So once you have the model downloaded, you can add the model within our out of the box tools, which is available with our image analyst extension, to do the inference or prediction part. So once we have that model, we'll be getting a parameter called text prompt. Here I can give parameters like buildings, shelters, rooftop, and we can run it. So once we run the model, we'll be getting the output like this. We can zoom to the output, and we'll be getting this exact segment building footprint from the imagery. And we can also have a count of the number of buildings detected, so that it is reducing my manual effort. Like if I have to like manually digitize this buildings, how much time it would have taken. But if I'm using this model, it will just take some minutes or some hours based on the capacity of our machine and all, and we'll be able to get the segmented output like this. So likewise, you'll be able to use this exam model for various purposes. It is not just limited with this building extraction. It can be used for this tree extraction, vehicle extraction from imagery. So different kind of workflows it can support. Now I'll show the oriented imagery, the street level view imagery detection functionality that we have. It is a recent addition actually. So most of the times we'll be having this street view imagery for this street view assessment or road condition assessment, or we may be having or we may be like collecting those imagery to assess the condition of this road assets, right? So in that scenario, instead of like manually assessing the condition, or instead of manually identifying the street assets like road assets within the street view imagery, we can have the model running on that imagery to get the automated detection or automated feature extraction. So here you are seeing some of my state level imagery that I have for the Mumbai region. So all the green dots that you are seeing is the point where the images were captured. So we have this functionality. So most of us will be aware of that only. So we have this functionality called oriented imagery catalog, which can organize our street view imagery, and we can view it in the form of this oriented imagery catalog or oriented imagery dataset. And once we have ingested our imagery into this oriented imagery data set, we can view it in the form of this oriented imagery layer. So we have this explore images option available here. And if I click on a particular location here, it will be showing the corresponding street view also. So you can say that for this area or field of view, it is showing me the corresponding street view within this oriented imagery viewer. So here, as you can see this, I had a street light. So I wanted to identify the exact location of the street light from this oriented imagery. But if I have to manually do that, I might have to go for a field inspection, or I might have to go to that road and have to collect the spatial or geospatial coordinate of that street light, right? But instead of that, if we have this imagery which has been captured already, I can run a model on this oriented imagery catalog directly. So I'll show how I have done this workflow. So here I have selected my OAC catalog. I have added my street view detection, street light detection model, and I have ran this model. So once I ran this model, I was able to get the position or the detection output of this model on my base map. So here you are seeing this yellow bounding boxes, right? So this yellow bounding boxes means that on this particular position, a street light has been detected from this oriented imagery, and this is the corresponding position on the map. So we can just like verify whether our detection is right or not. So you can see that we have a street level street light detected here, and I'm just changing my field of view here. And as I click on the map, it will change the view here in this catalog. So as you can see that in my view, in this field of view, one street light has been detected, and this is the exact position on the base map. And we can see that a corresponding street light is also there in my street view imagery data. So it means that my detection is right and my detection is accurate. So likewise, we can have this model to extract the street level feature information using this automated AI models. And now I'll touch upon some of the NLP use cases. So I mentioned about this Mistral LLM model during the presentation, right, which will help us in doing this automatic classification. So Mistral LLM model you will be able to access through our ArcGIS.learn library, and you can fetch in the Mistral model using that, and you can define the classes. So here in this workflow, I was trying to classify set of crash reports into three different categories: fatal accident, minor accident, and pedestrian involved. So I was having like set of news reports which is having this details on when that accident happened and was it fatal and how many injuries were there and how many deaths were there. But if I have to manually classify it, it will be a very long lasting process. So what I did was that we can call this Mistral model. I'll just give an example. For fatal accident, I just gave a sentence example. Similarly, for minor accident, also I gave an example. Similarly, for the pedestrian involved. So when I gave that example, that model tried to understand whenever a new report or whenever a new sentence is coming in, that model will try to like identify or automatically classify that sentence into any of these three categories. So I use that functionality. I gave the example, and when I predict and I gave my news reports as an input to the model, and I got my predicted result like this. And in order to better visualize it, in order to have better insights out of it, I took my results into a dashboard, and here you can see that these are the news reports I have given. And the news reports are like speeding car lost control and fatally struck two women. So here we are having this keyword fatally. So if I click on this, I can see that my model has been automatically classified this into fatal accident, and it identified the location from this report. So I mentioned about this entity extraction model, right? So it tried to identify the location information, and using this geocoding capabilities of ArcGIS, I could find the corresponding location within the map. So similarly, I have classified a set of news report, and this is like we can see the keyword killed. So it is also classifying it as a fatal accident, and it is showing the place where that accident has happened. So likewise, I have automated for a set of news reports. If I had to manually do it, it would take some time or some days. But using that model, I could do it instantly, and I could visualize the result in a dashboard, so that I can derive a better insights and I can share it with my colleagues or my organization members, so that they can also have an analysis on it. So finally, we can go to a notebook based workflow, which I mentioned during the presentation, which is the estimation of lost biomass due to a wildfire happened in Karnataka. So in February 2019, actually a bad or a drastic wildfire happened in Bandipur National Park. You can see this newspaper reports that was released at that time, and this is the satellite image of the wildfire affected area. And you can see that a major portion or a significant portion of this national park has been affected by this wildfire. So it was during the 21 to 26 February 2019 period. And I wanted to identify how much CO2 must have emitted due to this wildfire. So we know that when this burning happens, a considerable amount of CO2 is emitted to the atmosphere. So I wanted to analyze how much quantity must have emitted to the atmosphere during that wildfire. But for that, first I have to estimate the biomass before the wildfire and after the wildfire, right? But for that, what I have done, what the workflow we have done is that we had this JEDI point cloud data. So JEDI is this global ecosystem dynamic investigation data, which had this biomass points. So we used that biomass point data, and we trained a machine learning model to use this point data to predict a biomass surface, and we have used a set of explanatory variables like elevation, slope, aspect, NDVI, RVA, radar vegetation index, burn ratio, and we created a predictive model which will predict the biomass surface using this explanatory variables and GeoAI point data, and we predicted the biomass surface before the fire and after the fire, and we computed the change. So this is the workflow that we have performed. This was our goal, prediction of biomass surface. And with the prediction, we estimated the CO2 that has emitted due to that particular wildfire incident. And for this, we used the data from our repository. So, oh, the entire workflow I have done using image services, not by downloading each of the images separately. I have connected directly to the Copernicus repository. So from the Living Atlas page, we also have this capability to access this image service. You'll be able to access Sentinel image services, Landsat image services. So in a similar manner, we can have a list of image services or a repository. We'll be able to access it. So I have used this Copernicus 30-meter DEM data, and I have used that to calculate slope, aspect, and finally, I have used this Landsat data to calculate the rest of the explanatory variables like NDVI, normalized difference vegetation index, NBR, normalized burn ratio, and I have also used the Sentinel-1 ground range detected SAR data to calculate this RVA or radar vegetation index. And once I had all those model, I trained a model. I trained a random trees regression model using the raster analysis capabilities of ArcGIS. So we have this module which I mentioned before, ArcGIS module. It has a raster analysis module. So using that module, we'll be able to call this regression model within our notebook platform. And I used that capability to train a model, and I created two outputs, one for pre-fire, like before the wildfire happened, and one after the fire happened. So I calculated the biomass first surface for January 2019, and I calculated the biomass surface after the wildfire, that is for March 2019, and this was my prediction in the January 2019 as well as in March 2019. And we can see that a considerable amount of biomass has been lost. All this nearly white patches are indicating this lost surfaces, like biomass lost surfaces. And then we ran a change detection model on top of it to identify the regions where the changes have happened. And here in this output, this -1 pixel values are indicating the regions where uh, changes have happened, and the 0 pixel values are indicating the regions where no changes are there. And using this number of pixel values changed, we calculated the CO2 emission, and we could identify that around 46,684 tons CO2 were emitted during that particular wildfire incident. So similarly, we can have this predictive analysis model or estimation or classification model to like enhance our insight. So here I had developed a analysis model or predictive model for biomass surface estimation, and I used that output to further enhance my results to estimate the CO2 that must have emitted due to the wildfire. So similarly, you will be able to use such models and functionalities for your day-to-day workflows for various use cases and all. So it will help you in reducing the like manual labor that you are doing. It will help you in automating and doing the things efficiently and effectively. So, in short, we have covered these many things. So, we have seen ready to use GeoAI models. We have seen some of the tools and how we can use within the platform or within the notebook, how we can train the model, and within ArcGIS Pro, how we can use the model. And we have seen how we can bring the output into web apps so that we can visualize it better and analyze it better.